All right, so now we're going to be starting Chapter 2. Chapter 2 is all about descriptive statistics. These are procedures and values that describe a particular data set. The first thing we're going to look at is known as a frequency distribution. In a frequency distribution, we're going to organize a set of values into a table. We can do an individual frequency distribution, and that's almost always used with qualitative or categorical data. For example, I might divide up into class standing, freshmen, sophomore, juniors, seniors, and then just count the frequency of each of those class standings. But a grouped frequency distribution is used with quantitative data or numeric data, and that's what we're going to look at now. To do this, the first thing you need to do is decide on the number of classes you want. Usually that's a number between 5 and 20. And then you calculate the class width by calculating the maximum value minus the minimum value and divide by the number of classes you chose in step 1. You should then round that number to get a nice even number. Step 3, you want to find the lower limit of the first class, and that can either be the minimum value or a number slightly smaller than the minimum value. Then add the class width to this lower limit to get the next lower limit, and so on and so forth to get all of the lower class limits for all of your classes. Then you use these lower class limits to get the upper class limits, such that the upper class limit for class 1 and the lower class limit for class 2, they come right up to each other, but do not overlap. This is known as all-inclusive and mutually exclusive. Now you just make tally marks to count your frequencies for each of these classes, erase the tally marks, and replace them with the actual numbers. There are different types of frequency distributions that we can look at besides just the basic one, which we just went through. The next one we use is relative frequency. Now, the relative frequency of a class is that particular class's frequency divided by the total frequency, and we can denote these relative frequencies as decimals, fractions, or percents. We can also look at cumulative frequencies, which is the sum of the frequencies for that class and all of the classes before it. So the cumulative frequency for class 3 would be the frequency from class 1 plus the frequency from class 2 plus the frequency from class 3. Then you can use the relative frequencies and the cumulative frequencies to make relative and cumulative frequency tables. Now, consider this example that we have here. In this example, the lower class limit for class 1 is 60. The upper class limit for class 1 is 63, and we have 1, 2, 3, 4, 5 classes. Notice that the class width is the difference between two consecutive lowers or two consecutive upper class limits, and the frequency for class 1 is 2. That means I have two numbers in my data set that fall between 60 and 63. I don't know what those two numbers are. They could both be 60, they could be 61 and 63, but all I know is that the frequency of the numbers between 60 and 63 is 2. Now we're going to use this example to answer a few questions, so be sure and keep this slide handy. So first, what is the class width of our example? Why don't you pause the lecture and answer that question? Well, it's 4, because 64 minus 60 is 4. But notice, if you had taken any two consecutive lowers or any two consecutive upper class limits, you still would have gotten 4. What is the relative frequency of the third class? Write your answer as a decimal. Pause the lecture and answer that question. Well, it's 0.45 because the frequency for class 3 was 9. The total frequency, if you added up all of the 5 frequencies, you got 20. And 9 divided by 20 is 0.45. What is the cumulative frequency of the third class? Pause the lecture for a minute and answer that question. Well, the frequency of the first class plus the frequency of the second class plus the frequency of the third class is 16. Thus, the cumulative frequency for class 3 is 16. A histogram. A histogram is a way of doing a graphical representation of the frequency distribution. In a histogram, the bars must touch. There can be no gaps between the bars. The horizontal axis represents the classes of data values, and the vertical axis represents the frequencies. Here is an example of a histogram for the example we have been using. We can also do a relative frequency histogram. The only difference is that we'll be using the relative frequencies on our vertical axis. And here are the relative frequencies. Recall that the relative frequency of class 3, here's class 3, was 40.45, 45%. So this is a relative frequency histogram for our example. A frequency polygon, let me go back just a second and show you. I used blue ink to color in all of these bars, but I really didn't need to know the blue ink, have all the bar here with all that ink. I really just needed to know, if I could put a dot right here just to express the height of bar 3 and a dot here to express the height of class 1, then what I have is known as a frequency polygon. It's just the dots at the height of each of those bars without the bars being drawn in. So the line segments are then connected, and we put these points at the class midpoint, the middle of those bars. And the height of where that point or that dot is located corresponds to the frequency of that class. And then we drop the last one down to 0, and the first one down to 0, and the last one down to 0. You can see the text for an example of a frequency polygon. We also have what's known as an ogive, and an ogive is similar to the frequency polygon, except that we put the dots where the cumulative frequencies are, and on the right side we do not drop back down to 0. There are other graphs that we might be considering to look at. A dot plot, not very useful, not very common, but we have our horizontal scale is the scale of values, and we just put a dot vertically to represent each data value. A stem and leaf, where we take our values and we split them up into, we put a line where the last digit is, and the stem is all the digits to the left of that last digit, and the leaf is the last digit. You again can look at your book to see examples of this, and you'll get more practice with this type of graph in your Minitab lab. Bar graphs look a lot like histograms, except the bars do not touch in a bar graph, and it's used for qualitative or categorical data. A Pareto chart is a particular type of bar graph where the bars are listed from highest frequency to lowest frequency. And a pie chart is the second type of graph that's used for qualitative data. And most of you are familiar with pie charts. A scatter plot is when you have ordered pairs of data, and then we just plot these points on the XY coordinate plane, similar to what you did in high school. So here we have an example, and we have an X value of 23 corresponding to a Y value of 33. When we go to plot that point, there's that point right there, an X value of 23 and a Y value of 33. A time series chart is similar to, we still have an ordered pair, but in this case our X's correspond to time. It could be units of time of day, hours, weeks, months, years, and then the Y value corresponds to the value at that point in time. Then you connect the data points with line segments, and you get a time series chart. You're going to get some practice with this in Minitab Lab 2 when this lecture is over. The reason to draw these graphs often is to see the shapes of data, and there are certain common shapes that we are looking for. The first one is symmetric data. If when we draw our histogram and we fold it in half, if the left side roughly mirror images the right side, then we say the data is symmetric. Examples of symmetric data are the bell-shaped curve, sometimes known as the normal curve, and uniform data, which uniform data takes on the look of a rectangle. So it's a histogram where all of the classes have the exact same frequency, or approximately the exact same frequency. Sometimes data is not symmetric, though, and it is skewed to one side or the other. If most of the data values are on the left side, down here, at the left side of the graph, and then we have what's a tail on this side, so we have the data is going down to the right. I'm sorry. most of the data is on the left side of the curve, and the tail is on the right side of the curve, then we call that skewed right data. If the tail is on the right, we say it's skewed right. In skewed right data, the mean will always be greater than the median. Skewed left data, most of the data is going to be here on the right side. Our tail is here on the left side, and in that case, the mean will always be less than the median. That's the end of the first part of our lecture on descriptive statistics. It's now time for you to go try a few of the assigned problems from sections 2.1, 2.2, and 2.3, and especially to do the Minitab lab, Lab 2, which shows you the procedures to have Minitab do most of these graphs for you.